We are discussing the IIT-JAM 2017 modern physics problem. This problem is related to the relativity. Consider an inertial frame S' moving at a speed c by 2 away from another inertial frame S along the common x-axis where c is the speed of light. As observed from S. A particle is moving with c by 2 in the y direction as shown in the figure. The particle as seen from S is. So, a particle is traveling along y direction with the speed c by 2. Frame is moving in this direction. So, a person in this frame would observe both velocities along ux and uy. So, resultant velocity u in this frame would be ux square plus uy square. The velocity particle in frame S is given by ux is equals to ux test plus v divided by 1 plus ux test v by c square. Similarly, uy would be uy dash into 1 minus v square by c square divided by 1 plus ux dash v by c square. In frame S dash, ux dash is equals to 0, uy dash is equals to c by 2 and v is equals to c by 2. So, the value substituting these values above equation, we get ux is equals to 0 plus c by 2 divided by plus 0 equals to c by 2. Uy will be c by 2 1 minus c by 2 square by c square divided by 1 plus 0 equals to c by 2 1 minus 1 by 4 equals to root 3 by 4 c. So, the velocity, here you can write component of velocity. Velocity in frame S is given by u is equals to ux square plus uy square, that is c by 2 square plus root 3 by 4 c square is equals to root 7 by 4 c. So our correct answer would be option C. This question is related with the hydrogen atom. Here, consider a Rydberg hydrogen-like atom in a highly excited state with N around 300. The wavelength of radiation coming out of these atoms for transition to the adjacent state lies in the range. We have to determine what is the range of the emitted radiation or wavelength for the emitted radiation from 300 to N299. So, according to Bohr's theory, wavelength of electron is given by R infinity 1 by NF square minus 1 by NI square. According to question, NF is equals to 299 and Ni is equals to 300. So 1 by lambda is equals to R infinity 1 by 299 square 1 by 300 square. It implies lambda is equals to 299 square into 300 square divided by 300 square minus 299 square to 1.09 10 to the power 7 wavelength. This is after solving we get the value of the other 1.22 meter. That means the emitted radiation would be in the range of radio frequency wavelength. This problem is related with the blackbody radiation. In the radiation emitted by a blackbody, the ratio of spectral density dash frequency to mu and mu will vary with mu as. So, is given by u of 2 mu 8 pi h 2 mu q divided by c cube e to the power 2 h nu kbt minus 1 into 8 pi h mu cube by c cube e to the power h mu kbt minus 1. So we can check it out. Mu cube would cancel, cross with cancel. So there would be mu2 dependence on frequency would be like mu equals to e to the power h nu by kbt minus 1 into e to the power 2 h nu by kbt minus 1. That can be written as e raised to the power h nu by kbt minus 1 into e to the power h nu kbt minus 1 into e to the power h nu kbt plus 1. So this ratio depends upon 1 by e to the power h nu by kbt plus 1. That means option B. A photon of frequency mu strikes an electron of mass m initially at rest. After scattering at an angle phi, the photon loses its half of its energy. If the electrons recoil at an angle theta, which of the following is or are true? So, according to Compton formula, we have lambda dash minus lambda is equals to h by mc 1 minus cos phi. In general, it is always theta, but the question is saying you can take it phi. So, 1 by cos phi. Further, but lambda is equals to c by mu dash minus c by mu equals to h by mc 1 minus cos phi, but mu dash is equals to mu by 2. So, c mu by 2 minus c by mu equals to h by mc 1 minus cos phi implies 2c by mu minus c by mu h by mc 1 minus cos phi, or c by mu is equals to h by mc 1 minus cos phi, which implies cos phi is equals to 1 minus mc square by h nu. That means our first option is correct. This option is wrong. So let us check out for the option third. The ratio of magnitude of momenta of the recoiled electron and scattered photon. Applying conservation of momentum along y direction, we get h mu dash c sin phi is equals to p sin theta implies p by h nu dash by c equals to sin phi by sin theta. Thus, our option C is also correct. Change in photon wavelength, this is incorrect. It would be h by mc minus 1 minus cos phi. Thus, option A and C are correct answer. For an atomic nucleus with atomic number Z and mass number A, which of the following statements are? Nuclear matter and nuclear charge are distributed identically in the nuclear volume. They are not distributed identically. They are not distributed identically. Nucleus with Z greater than 83 and A greater than amit alpha identically, yes. This statement is correct. Atomic number nucleus with having atomic number Z greater than 83 emits alpha particle. The surface contribution to the binding energy is proportional to surface is defined as 4 pi r square. That means 4 pi r is r naught a की power 1 by 3 square, that is 4 pi r naught square, that is a की power 2 by 3. So Vs is proportional to a to power 2 by 3. That statement is also correct. Beta decay occur when proton to neutron ratio is large. No. This statement is correct. Beta decay occur when proton to neutron is small, and positron decay occur when proton to neutron ratio is large. So correct options are B and C. Consider a one-dimensional harmonic oscillator of an angular frequency of omega. If 5 identical particles occupy the energy level of this oscillator at zero temperature, which of the following statements about their ground state energies are true? So we consider case first. Particles are boson. In this case, n is equals to 0. All particles would be in ground state. So energy for in this state would be 5 into 1 by 2 h cross omega, that is 5 by 2 h cross omega. Case second, particles are fermion. In this case, we would be having n is equals to 1, 0, n is equals to 1, n is equals to 2. Means each state occupied 2 electrons. So the energy of particle in this state would be 2 into 1 by 2 h cross omega plus 2 into 3 by 2 h cross omega plus 1 into 5 by 2 h cross omega, that is 4 h cross omega plus 5 by 2 h cross omega equals to 13 by 2 h cross omega. Case 3, spinless fermion. Spinless fermion are those particles which occupy one particle in one state only, that is n is equals to 0, 1 particle, n is equals to 1, 1 particle, n is equals to 2, 1 particle, n is equals to 3, 1 particle, and n is equals to 4, 1 particle. So in this case, energy would be 1 by 2 h cross omega plus 3 by 2 h cross omega plus 5 by 2 h cross omega plus 7 by 2 h cross omega plus 9 by 2 h cross omega. 9, 7, 16, 16 or 9, 25. So 25 h by 2 h cross omega. Let us check out our option. Spinless fermion 25 by 2, particles are boson, true, particles are electron, true. So option A, C, D are correct. A particle of mass m is placed in 3-dimensional cubic box of side A. What is the degeneracy of energy level of energy? 14. The energy of particle inside a cubic box is E nx ny nz equals to pi square h square by 2 ma square into nx square plus ny square plus nz square. So let us check it out here. Nx, nx, ny, nz, here en. So for 111 energy is 30, that is ground state. 211 energy is 6E0, that is first excited state. 221, that is energy is 9E0, second excited state. Then we would be having 311, energy is 11E0, that is third excited state. 4th is 222, energy is 12E0, energy that is fourth excited state. And 1, 2, 3, the energy would be 14E0, and this is fifth excited state. So for energy En equals to 14h square pi square by 2ma square, that is equals to pi square h square by 2ma square equals to nx square plus ny square plus nz square cancel. So nx square plus ny square plus nz square is equals to 14 implies nx, ny, nz is equals to 1, 2, 3. So degeneration in this state is 6, and these are 1, 2, 3, 1, 3, 2, 2, 1, 3, 2, 3, 1, 3, 1, 2, 3, 2, 1. So the answer is 6. Degeneracy is 6. For a proton to capture an electron to form a neutron and neutrino assumed massless, the electron must have some minimum energy. For such an electron, the de Broglie wavelength in picometer is. Now, let us understand first this reaction. An electron capture process is P plus E gives us N plus neutrino. So, considering energy conservation, that is MP_C square plus ME_C square equals to Mn plus E of E equals to Mn_C square plus M_C square plus Tn plus Tmu, where Tn, Tmu, E is the kinetic energy of neutron, neutrino and energy of electron. Thus, further, mu_c square equals to 0 as mu is massless particle, Tn and Tmu must be 0 as we required minimum energy are also 0 for minimum energy. And in this present scenario, we can neglect MeC square as this is very small, MeV. So we are left with energy of electron is equals to Mn minus Mp into C square, which is equals to 1.675 minus 1.673 into 10 to the power minus 27 into 3 to 10 to the power 8 square equals to 1.8 into 10 to the power minus 13 joule. The relativistic energy of electron is given by E square is equals to P square C square plus Me square C to the power 4. So we can neglect this term So P would be E by C, as MC square is neglected. The de Broglie wavelength is given by that is equals to H by P. So H is 6.6 into 10 to the power minus 34. P is E by C, that is 1.8 into 10 to the power minus 13, and C is 3 into 10 to the power 8, which give us 0.6, 1.1, 13, 8, 21, 1.1 to 10 to the power minus 13. That is 11. So that means we are having a 10 to the power minus 12, 1.1 picometer. So our answer for this problem is 1.1. So this question is related with the electron microscope. In an electron microscope, the electrons are oscillated through a potential difference of 200 kilovolt. What is the best possible resolution of the microscope? Resolution of microscope is given by wavelength lambda is equals to H by 2m E, that is H by 2m E V, which is 6.6 10 to the power minus 34 root over 2 into 9.1 into 10 to the power minus 31 into 200 into 10 to the power 3 into 1.6 into 10 to the power minus 19. This value would give us 2.75 into 10 to the power minus 12 meter, which is 2.75 picometer. So our answer is 2.75